guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about multithreading in Java. In Java, multithreading essentially allows multiple tasks to run simultaneously to improve a program's efficiency. But first, let's get started with some key vocabulary. So, what's a thread? A thread is like a worker in a factory. Normally, Java runs everything in a single thread, meaning tasks happen one after another. But with multiple threads, tasks can happen concurrently, just like multiple workers in a factory. So, to create a thread, there are two main ways: extending the thread class and using the runnable interface. So let's talk about the first way, which is extending the thread class. So as usual, I'll just code it. So let's create a new class to house our threads, right? Let's make my thread, and we want to make sure this extends thread. So let's create a method called run, just to kind of visualize how our threads work. I input the name. Public void run, right? So let's just create a simple for loop to showcase our threads. So for int I equals 1, I is less than or equal to 5. Less than 5. I increments by 1. And we can just print out using IntelliJ's built-in shortcut for printing fout thread running, and then running which instance, which is I. Next, let's look at our main class, right? So we can make a different class, and we can just have public class main. I'm naming it main because it has to match my file name, which is main.java. So let's create our main method, which is public static void main string square brackets and args. So let's create a new thread, right? The way you do this is by doing, let's just call it my thread. So my thread, sorry, I spelled thread wrong. My thread, and let's name it T1 for thread 1, right? So then we can just create a new my thread, which is how you do it in Java. Next, we can just do t1.start, which is essentially starting this thread. So in this code, we essentially create a thread by extending the thread interface. The run method contains a code that runs in a separate thread. When we call thread start, Java begins running this code in the background. So let's just run this to see how it works. See, it's pretty fast. The compiling rate is pretty fast compared to just having a single thread. Next, let's talk about the next method for using threads, implementing the runnable interface. So we can essentially do kind of the same thing. So I'm going to keep my main method. We have to create a new class. Actually, no, we can keep the same class. But the only thing we change, instead, we can just change this to my runnable, since we are going to be using runnables. And instead of extending thread, we're going to implement the interface called runnable. Implement runnable. Spelled implement wrong. Implements runnable. So we can essentially keep this code the same just to showcase how runnable works. So the only thing we change is our main method. So in here, we can just create a new thread. But instead of using my thread, we just say thread t1. We can just keep our name the same. Equals new thread. New my runnable. So this is essentially the line that creates the thread. So next we can do t1.start just to see how our thread works. So we can run this code. We can see that it performs similar to the last execution using extending the class thread. So using runnables is better if you don't want to extend threads. So in this code, we implement runnable, put the main logic inside run, and we pass it to a thread object. Next, let's talk about running multiple threads. So, as usual, I'm just going to code it. So, we can change this to my task because we're going to use runnables. Or we actually are going to use runnables, but you'll see why in a second. So, instead of printing thread running, class my task increments runnable. So, instead of just printing thread running, let's just print our current thread and the name of our current thread, right? So, we can do thread dot current thread dot get name, which essentially gets the name of our current thread, and we can add running, so we know which thread's running simultaneously. Now let's change our main method. So in this, instead of changing to my runnable, we're going to change it to my task, since we subsequently changed our class name, our first class name. So instead of doing t1.start, we're creating a new thread using the same exact format as before. Thread, let's call it t2 for thread 2. Thread t2 equals new thread and new my task. Sorry, I spelled thread wrong. And for this, we can just do t1.start, t2.start. And now let's run this code to see what it achieves. See, it kind of alternates between 1, 0, 1, 0, 1, 0 running, which shows how efficient two threads can be. So essentially, this code we create two threads and both run at the same time. Since Java decides which thread runs first, the output order may change each time you run the program. Like for example, it's like 1, 0, 1, 0, 1, 0, 1. It could change. Instead of it being perfectly alternating, you see that it's 1, 0, 1, 1, and 3 zeros. It changes each time you run it, see? Next, let's talk about pausing a thread with the built-in sleep method. So we don't need another class for this. We can just keep our main class. So let's say we have a for loop, right? I'm just going to create that just to showcase how the sleep method works. So for int I equals 0, I is less than 5, and I increments by 1 each time, we can just print out count plus I, just to see. Count, and we concatenate I onto the end of it. So instead of using these threads, we can just have that. We can use try catch blocks, which I've previously mentioned in the previous videos. So we can have try thread dot sleep, and let's make it sleep for 1 second. It's 1,000 because it's in milliseconds, right? So thread dot sleep. Next, let's add our catch part. So catch, and a catch is an interrupted exception. Let's just call it E. We've talked about handling exceptions in a previous video, so if you don't know the basics of that, make sure to check it out. So now let's do e.print stack trace. This code essentially pauses the thread for 1,000 milliseconds, which is the same as 1 second. This is useful when you need delays between actions. So here's some key points about threads. Threads allow parallel execution to improve program performance. You can use thread or runnable to create these threads. Sleep pauses threads, and multiple threads can run independently. Multithreading makes programs run faster by doing multiple things at once. Thank you guys for watching this Super Saiyan program tutorial, and see you next time.